Hey guys, here's the video for 3.15 daily practice. I actually want you to try the investigation first and then we'll go over it. So go ahead and pause the video, try the investigation. All right, so my guess is you guys might have something that's going to disagree with what I show you, but that's why I wanted you to try it. So if you have what I have, great. If you don't, fix it. So predict what we think the solutions on the number line will look like. Now, we have talked about when I have like x is greater than 5, greater than on a number line is to the right. But because this one has a negative in front, I think it's actually going to change it up. Because I'm saying I want numbers that are opposite sign from x, and I want them to be greater than or equal to -4. So I'm actually going to predict that this one might go left. By that I mean anything below, and again we're talking opposites. So if I'm doing the opposite of this -4, or sorry, of -x, maybe it's going to be the opposite of -4 also. So I'm going to say actually anything below 4 because I'm going opposite. Let's see if that works. What I'm going to do next is take the values shown and I'm going to put them into our inequality. So if I have 3, my inequality would say, I'm going to just substitute this for x, -3 greater than or equal to 4. Is that true? Oops, sorry, I lost my negative. Greater than or equal to -4. That one is true. What about a negative times a -3 greater than or equal to -4? Well, that's going to just become +3, so yep, that works. What about -4 greater than or equal to -4? Yep, that's equal, so that works. So we got a lot of solutions here. What about a negative times a -4 greater than or equal to -4? Again, that's going to become positive, so yep. All right, then this one, what about -4.0001 greater than or equal to -4? This is tricky, but if we think about a number line, this number here on the left is actually going to go past -4. So if we say maybe -4 is down here, -3, -2, 1, 0, 1, 2, 3, 4. If -4 is right here, -4.01001 is right next to it. So that actually doesn't work because that's below -4. So nope. All right. What about negative? So again, we're thinking opposites. That's going to become positive. Positive bigger than a negative? Yes. So all of these, A, B, C, D, and F, all of those are solutions. So if we think about our number line, we know 3 is a solution. We know -3 is a solution. We know 4 is a solution. -4 is a solution. -4.001 is a solution. But positive 4.001 was not a solution. So that means anything 4, as we already said 4 was a solution, or lower worked. Interesting. So let's keep going and see if we can figure out why that is. So first we're going to look at this table. We have some values for x, and then we have x plus 2. So how are these top numbers and rows related? So here we can say this is like start with a number and add 2. So -4 plus 2 is -2. -3 plus 2 is -1. -2 plus 2. So basically all of these are adding 2. So x plus 2 is just 2 more than x. Okay, so we think about this with the equation x plus 2 equals -2. We can solve this with our inverse operations, right? We subtract 2, and we know that x equals -2 minus 2 is -4. We see that on the table right here in the first column where x value of -4 plus 2 gave us -2. Now we can think about the inequality. X plus 2 is greater than 3. What value of x makes this true? Well, same thing. Inverse operations goes away. We are left with x is greater than 1. So where do we see an x value of 1? When x is 1, we have x plus 2 is 3. So x plus 2 is greater than 3. So x plus 2 greater than 3. Look at this row. That would be all of these boxes right here. And so we can see these are all values where x, look at the top row, is greater than 1. So where do we see them in the table? The last 4. Cool. All right, now you guys on your packet have some partner practice. It's similar with the tables, but I actually want you to pause, try number 1 and try number 2. I'm only going to show number 2 because I want to make sure our video has enough time, but you should be able to compare it to number 1. Okay, hopefully you've just paused the video and now you have numbers 1 and 2 done. Now I'm going to go over number 2. So this is partner practice problem number 2. So we're going to consider the inequality negative 2x is less than 6. Again, we're going to think about what values of x will make this inequality true. I actually want to hold off on that because I want to test the values down here. So if I have negative 4, then negative 2x, or negative 2 times negative 4, is 8. Negative 3 times negative 2 is 6. Negative 2 times negative 2 is 4. Negative 1 times negative 2, 0 times anything. 1 times negative 2. Now we're in the negatives. 2 times negative 2. 3 times negative 2, and 4 times negative 2. So if we look back at our inequality, I'm looking for values that are less than 6. So I think I see those right here. So what values of x give me these are right above. And it looks like I have any x value that's less than negative 3. So let's go ahead and graph that. We said x is less than negative 3. I don't have an equal sign, so I'm going to have an open circle, and less than goes this way. And I just realized, actually, I made a mistake because look again at your x values up here. I have negative 3, but then I have negative 2. Negative 1, 0, 1, 2, 3. So it's actually going to go this way. So let's think about this for a second. I want to know, why are the solutions for this one different from the one you did in number 1? So what we're thinking of right now is these x values, we have negatives up here, and then we have positives down here. Now when we switch to positives, we end with negatives. That's all because this coefficient here is turning around the signs of our numbers. So we can think about this as they're different, and I want you guys to put this in your own words, so I'm actually not going to give you something to write. But in your own words, right here, I want you to explain why these are different. The one I just did should go to the right. The one you did earlier when you had positive 2x less than 6, your arrow should have gone to the left. But when we had that negative 2x, the arrow goes to the right. So to fill in those key points, we can solve an inequality just like an equation. We've been talking about that all week. When we use the equation, that's going to give us something called the boundary point. Basically the point that you graph. Before you decide which way your arrow goes, this is the point you're graphing. We can test values on either side to see which way the solution set goes. That's like, which way does your arrow go? And the last one is this new stuff for today. Graphs of inequalities with negative coefficients seem to point the opposite way. What I mean by the opposite way, you guys, is look back at your previous example. We started with the less than sign, but then our arrow went to the right. Again, that was all because, look back at your original equation up here, we had the negative 2x. So this negative on our coefficient made the less than sign become a arrow that was going to the right. So again, you guys have a stop and jot. I want this to be in your own words. I just explained it in my words. I want you to explain it in yours. Why is that arrow turning around? Go ahead and write your response, and then you can go ahead and finish up the rest of the packet. Good luck. Please send an email if you are confused.